Hey, this is Ryan Jones with serverlessguru. In this video, we're going to be covering something called Firestore. And Firestore is part of the Firebase suite of products and services. And what it allows you to do is create a NoSQL database that can scale to global size. And so in this video, we're going to cover the documentation and kind of get a feel for what it is, and talk about some of the things that I find the most interesting about the service. Let's go ahead and jump in. So Cloud Firestore, store and sync app data at global scale. It's a NoSQL database built for global applications. Cloud Firestore is a NoSQL document database, and it allows you to store, sync, query for mobile and web applications. So when it comes to querying, you can kind of use any structure that you like. Because it's a document database, you can kind of dump any type of data structure that you want and utilize it in that way. So basically, you can structure your data using collections and documents, and then build hierarchies to store related data together. As they say with databases of this kind, the closer the data is, the closer the related data is together, the faster you can get the data out. It says all queries can scale with the size of your result set, so your app is ready to scale from day one. So from day one, you start using a service and immediately can scale to your needs. And you can also build truly serverless apps, right? So at serverlessguru, we talk about serverless stuff a lot. And one big thing that I like about Firestore is that there's this argument happening between, do you use REST or do you use GraphQL? The GraphQL community is saying that REST is outdated, it's antiquated, and although REST does require you to create basically to do CRUD functionality with REST, you have to create 4 different endpoints, right? To do CRUD functionality with GraphQL, you have a single endpoint. Behind that, you have a concept called resolvers. Those resolvers can basically do anything that you need. They're basically GraphQL queries and mutations, and then they have resolvers on the other side of that, which then connect to your database or to something like a Lambda function, or to anything else that you want, right? So normally the way that you would write something like that is you would have an API endpoint which has the code required to talk to your database and then communicate back to the client, right? So request and response mapping. And so what ends up happening is that a lot of APIs are actually just requests and responses, and that's the only point of the API, right? Is to communicate back and forth with your database. What Firestore allows you to do is remove the need for the web API. Just write the JavaScript and then use something called security rules, which Firestore has, to then limit access only to your website, or only to an IP, things like that, right? And then you can even limit the people who are interacting with your data, and you can basically say, okay, only the username Joe can interact with Joe's data, and that's it. So that's very powerful, and it saves a lot of overhead for developers. Because when you develop a GraphQL endpoint, or you develop REST endpoints, you really have to think about the naming conventions, how it's configured, how the backend supports it, all the underlying technology. If you're running servers, that's even more overhead. This allows you to remove that and also scale past the point of a server, and scale equally to something like running a GraphQL or REST endpoint through a Lambda function or Cloud function. So it's very powerful. And so, as it says here, serverless compute product, and you can execute hosted backend code that responds to database changes. So, if you're familiar with triggers, this happens with regular SQL databases. It also happens with DynamoDB if you're familiar with AWS. Basically, when a write comes in, or a delete, or an update comes into your database, it can then trigger off of that and run something like a Cloud function, and that Cloud function can be written with Node, Python, Go, Java, and it can basically then look at the data that just got updated and then do something with it. And it could be infinite things, right? If it was a URL to a image that just got uploaded, you could create a thumbnail out of that. If it was transaction data, then you could record that to some software solution that you have. If it was a image that you wanted to basically classify with some machine learning, or let's say it was click data, right? So like your user is using the application, they're clicking different buttons, you're recording those clicks, you're storing them in the database, and then maybe it's automatically pushing that out to a Cloud function and then running data analytics on it, right? So all that can kind of happen with this trigger off of writes, updates, deletes in Firestore, which is really powerful as well. You can also sync data across devices, online or offline. So this is something that's becoming a lot more popular and something that applications kind of have to be built with nowadays. Is that, imagine you went out on your nature trip and you were using Instagram and you're taking this super awesome video and then you try to save it and it wouldn't save because Instagram didn't support offline mode. You know, you would be pretty angry with that, and rightfully so, right? So what Instagram actually does, it allows you to take that video and then allows you to come back into Wi-Fi signal or cell signal, and it automatically starts that upload for you. And so that's what this does as well. So Firestore supports, you can automatically synchronize your app data between devices. So this is one device makes a change, it pushes it out to 1,000 other devices or 100,000 other devices. And it will basically notify you when data changes. So you can easily build collaborative experiences and real-time applications. It says that you can also use this access to make changes to their data at any time, even when they're offline. So allowing you to make offline mutations to their data. There's a service called AWS App Sink, and AWS is actually playing around with this as well, except you have to use kind of a GraphQL backend for this. But what it does is that underlying the GraphQL, you have offline support that you can actually do things like someone can write and it has an optimistic response. So it basically says, okay, you're sending this data to the database. We're going to assume that it's going to be a good response. And so we'll automatically update the front end before the response comes back. And that's kind of what optimistic response is with AWS App Sink. And it kind of covers a similar area of how do you do offline mutations. You kind of just assume it's going to work and you update the front end. And then once it actually comes in a Wi-Fi signal, you change it from there. You basically sync it. It also scales globally. So this is also Firestore is powered by Google's global architecture or global infrastructure. And so it's built to scale up to the scale of companies like Lyft, things like that. You can also focus on building the app instead of managing servers, right? So that was something I touched on a minute ago, was the overhead aspect. With Firestore, removing the servers is something that happened actually a couple steps before this, right? So Cloud Functions gets rid of the server management, containers get rid of a certain part of the container, or basically it goes servers and then containers and then Cloud Functions and then now Firestore, right? And so Cloud Functions or Lambda functions, they cover part of that process, but now with Firestore, it removes the need to have the Cloud function where its sole purpose is just to communicate with the database, right? And then we also have strong user-based security built in. So there's a security language that comes with Firestore and allows you to create patterns so that only certain things can access that data. And that's what I talked about a second ago with the username Joe is trying to access data. Username Joe can only access data that belongs to username Joe. And you can write that using the security language that Firestore supports. It also integrates directly with Firebase Authentication. So if you're familiar with that, then this has integration directly inside of it. So a couple of apps that use it as well, HomeAway and Hawkins Dynamics. So HomeAway was able to, basically it says that it was able to reduce 66% in development costs using CloudStore, right? So 66% reduction in development cost. And that's kind of the thing that I took away from this when I was at Google Next 2018, was that Firestore allows you to take away this development process that takes weeks, and it requires very granular detail, and it requires specialized training. And what you're doing is you're creating a headache in the future. Firestore says basically, why do we need this? It takes it away, and now you can basically just connect to your database directly from the client. You can write security rules to manage who can actually access that data, and from there you're kind of set to speed up your time to market. Hawkins Dynamics said that they brought product to new levels in 2 weeks. So they basically migrated from Firebase real-time database to cloud Firestore and shipped more powerful apps in weeks instead of months. So those both have case studies. If you want to read more about that, then check out the Firebase documentation for Firestore. But other than that, yeah, I mean, this is something I'm really excited about. It's something that I'm going to be probably making more videos about in the future. I really like what Google has done with Firestore, and it was one of the biggest things that I took away from the Google Next 2018 conference was that Firestore is really going to change web development in the future. So yeah, this was Ryan Jones with Serverless Guru. I hope you enjoyed the video. I will see you next time.